Hi class. So today I'm going to get started on animation. And while we'll delve into all the depths of computer animation and how we're going to make it work and all the digital tools, it's really important to start from the basics of why this works. So I'm going to start from old-fashioned animation. You might see devices in museums or old film. And we'll learn how that works first and then how that translates to the digital world. Now, a lot of animation revolves around this idea called persistence of vision. Now, we've since learned that there's more to the picture than persistence of vision, but it's a great place to start talking about. So, this is what happens. Let's say you're walking down the street, okay? So, a person looks at an image. You're walking down the street and you see a really nice building, a piece of architecture. You look up and go, oh, that's really nice, okay? Close your eyes real quick. If you close your eyes real quick, if the image goes away, what happens? If you close your eyes, someone from behind you puts a bag over your head. What happens in that case? And I think for my notes, I'll have a nicer example. You close your eyes. So you look at an image, if it goes away, it doesn't actually go away. It stays in your vision for a while. You can try that right now. Look at the screen. Close your eyes. Close your eyes. You can actually see it for a little bit before it fades. Okay, so it stays in your vision. For about 1/25th of a second, okay? And I put a big asterisk there. About. Different people are different. I don't like movie theaters because I can see the flicker. It bothers me. Other people, it doesn't bother them. So that's different between people. Also, some people says it because it stays in your retina, and that's actually true. Your retina takes time to respond to changes, but also it happens in your brain. Your brain holds on to that processing for a bit of time too. So exactly why and where it holds on, it's up for inquiry and up for debate. But that's not relevant for this course. What you just need to understand is this number roughly around there. If I close my eyes, if the image goes away, it actually stays there for a fraction of a second before it fades out. So this is actually really interesting. It's a limitation of human vision. What that means is you can't see very fast. You can't see fast motion because it blurs together, okay? But this actually means we can leverage this for doing animation. So the key here is if we can change the image, right? If a new image shows up before the persistence fades, right? If a new one shows up before before it fades, if you blink fast enough, you won't see the change at all. You won't see the blackout. You won't see it close and open up because it's too fast. Okay? You just see the result. So this property where if you change an image quick enough, black it out and change it quick enough, the eye doesn't pick up on that, just seeing the result, is how movie theaters, in traditional movie theaters, work. So let's look at this for a second. So traditional film. So what they would do is they would roll an image behind roll a series of images behind a lens. That would project onto a screen. Okay. So imagine I had this roll of film here. This is, Jim on holiday. Yay! And whoever's taking it doesn't care about Jim and starts looking at the mountain instead. And you can imagine this series of pictures, and here's Jim's, poor Jim, and we have the mountain. And you've seen these before, these rolls of film. You've seen this on TV and in documentaries or whatnot. So you have this film, and what you do is you put it on a roll, okay, and it comes out one end and goes on to another roll. This is a big roll, and then what you do is you put a bright light behind here to shine through the film, and then you put a lens over here. Well, that worked. Good job, computers. All right, it did not like my description of animation, apparently. Okay, we didn't lose too much. Good. All right, so we put a bright light here. This is my light. I'm going to annotate this. And then we put a lens over here. Actually, I'm gonna move that. Okay, well, I tried. Woo! Yeah, I tried. Okay. So we put a lens there. It focuses your picture onto a screen, and you see Jim on holiday. Okay? And there's the mountain. So you have this roll of film, and a light shines through, and it shines the picture into the lens, which projects it on a screen. There's one more piece of the puzzle here. We have this shutter. And so what the film actually does is it stops the film from rolling. It stops it. It opens the shutter. So I see the picture. It closes the shutter. And it moves to the next. So what you get is you get an image, black, image, black, image, black, right? So you can imagine then what the images on the screen are actually going to look like this. 3, 4, 5. Okay, you have Jim on vacation, and then you have blacked out. Then you have Jim on vacation, the next picture, blacked out, and then, so on and so forth. So in these cases here, it's open, closed. So every second picture is actually fully black. But you don't see a movie that way. When you go to a movie theater, even an old-fashioned one, you won't see it. Your eyes blend it together. So your brain would only see the pictures, not the blanks. That's assuming that you're doing it quick enough, okay? So let's do a demo of what this might look like. Yada. Okay, so I should probably do that. Yeah, so here's an example program. All it is I've set the frame rate. This is in the notes a little later. I've set the frame rate to 1. And I draw. And I'm going to draw a scene. And every second scene, I'm going to blank and not draw the scene. So I'm going to black it to black, clear it to black, and then I'm going to go black, scene, black, scene. In this case, my scene is just a circle. And then I've added some hotkeys where I can change the FPS and it'll print out the frame rate. So it'll start at 1 frame a second, so off, on, right? So you can imagine this is what's actually happening on a film. And I go 2 frames a oops, let's try that again. Come on, 2 frames a second, 3 frames a second. Cool, all right. 4, it still looks pretty choppy. 5, 6, 7, it's starting to get better, starting to get better, starting to get better. Okay, I hope it doesn't make you motion sick. Now, it's actually quite interesting what's going to happen here. My monitor is running at 60 frames a second. I'm not sure how fast it's recording. We might get a situation where I'm seeing something different than you're seeing, where it might go solid versus you, because if it's recording at a different interval than you're seeing it, you're going to have a problem here. So let's see how it happens. 16, 17, 18, 19, starts to look interesting. 22, okay, starting to look a little better. 25, 26, 27, 28, 29, 30. Look at that. It's pretty solid now. It's getting up there. Keeping in mind my monitor is at 60 frames a second. I'm curious to see how this is recording. 40. Now it's starting to look really solid. So download this and play with it yourself. I'm very curious. Okay, is it cutting out on your end? Like sometimes cutting out? That's where the frame rate isn't matching the display rate. Really cool stuff. And then 60, it's matched. There we go. Yeah, this is really cool. So I can see on my screen it looks different than on the recording screen. So download this and try yourself. At 60 frames a second, it looks a little gray. It's mixed into black and white, but it's not flickering as much anymore. It's actually pretty nice. It's not as nice as, a theater would be double this. It would open and close at 120 hertz to get to 60 frames a second, and I'm only able to do 30. So it would be nicer in a theater, but you can play with this. What's really cool now is if I go way above my monitor's actual rate, you'll start getting really strange effects where it lines up sometimes and doesn't line up other times for multiple frames. But if we go above the frame rate of the screen, it gets kind of weird. Anyway, that's something you can play with and think about what that means with the refresh rate of your display and what your limits are. Really neat stuff. So let's go back to our notes. Okay. So the key now is once we realize how easy it is to just show pictures, and even if it's blank in between or changes in between, the computer's okay, the brain's okay with it. We can start to show different pictures each time. So I can show a different picture each time. If they're similar enough, and the change is fast enough, then I get a series of then I get this conversion where I'm actually drawing this series of static frames, but you see this illusion of motion. Nothing's moving, you're seeing static frames, okay? I'm gonna go back real quick to my demo, and we can quickly add in int x equals 0 of the location of the circle, and then instead of having it at the center of the screen, let's make it at 0, and each time we draw, x equals x plus 1 mod width, so it'll circle around. And you can see that all I'm doing here, each frame it'll move a little further as I speed it up. Oops, what's going on? That was a typo. Let's try that again. Each time it draws, it'll move forward a little bit. As I increase the frame rate, you can see you get this illusion of motion. Cool. Really neat stuff. So nice and smooth motion across the screen. So this is how animation works. You have a changing scene and your brain fills in the blanks, and you can actually get away with a lot of change. Like arms can go like this, and the brain just fills in what's a natural thing for it to happen there. Okay. All right. Oh yeah. Did I write my demo on here? That was demo 1, and I have some slides to show real quick. Slide 2. So slide 2, flipbooks work this way, right? So you have these series of static frames. Even though it's moving, your brain filters out the change mostly. You can still see it a bit. It's a bit blurry because there's no shutter, and you get this illusion of motion even though it's just a series of static pictures, okay? So that's really cool stuff. I find that really cool. Now, the last thing I'll mention about traditional animation before I get into digital stuff is this idea that's called cell animation. You might have learned about that in a different class. And cell animation is just a recognition that when you make these old-fashioned frame-by-frame systems, whether it's a projector or whether it's a flip book, it's very labor-intensive. So to save labor, save work, what people realized is, hey, we can use transparencies like pieces of plastic. We draw the changing pieces on clear sheets. So we can reuse our backgrounds. We have a really cool background. Classic animation would do this. You have a series of backgrounds that were really well done. You do them once, but then you put these transparencies on top of it, on these transparent sheets. And these, so that you can, make the mouth move, make the person move. You can change everything without modifying that background. These are called cells. Okay. And then you overlay these cells to compose a scene. All right. That's pretty cool. So here's an example of cell animation. You have a very carefully drawn background scene that looks a lot nicer. It's much more expensive to do, but then you have this cell, this transparency, where you put the paint on there and you can layer them on top and make them move around so you don't have to redraw the background every time. And it doesn't mean you get one layer, you can get lots of layers. So you could imagine putting the mouths and things that change a lot on one layer, the characters that you can reuse from frame to frame on another character, and so on and so forth. So you layer them up, take a picture, you get, and then this is how cell animation works. So that's kind of neat. We'll come back to this because it actually influences how we approach some animation in digital systems as well. Okay, so we'll take a break there, and we'll come back and learn a bit more about how this translates into the digital world.